Hi everyone. Today I'm going to share with you the trigo question. Let's start. Now let's analyze the question. Given tangent to A equals to 4 over 3, and we are given also that A is in the first quadrant. So what do we know about first quadrant? All function trigo would be in positive. So your tangent will be in positive as well. So without using the logbook or calculator, we need to find the value of tangent A. So just apply the formula of the double angle. Okay, so tangent to A is equivalent to 2 tangent A over 1 minus tangent square A. Okay, and since we have the tangent to A, so let's just put 4 over 3 in. Now, at the same time, tangent A is the things that we want to find, so we can let x be tangent A, be the things that we want to find, and so that we can make the whole equation look much easier. So 2x over 1 minus x squared. Now cross multiply it to get rid of the fraction mode. So we will have 4 minus 4x squared equals to 6x. Now whenever we see x squared, okay, to the index 2, we know that we need to solve this quadratic equation. So let's rewrite this equation so that it is in a format of ax squared plus bx plus c equals to 0. So bring this to the other side so that the coefficient for x squared will always be positive. So we will have 4x squared plus 6x minus 4 equals to 0. Now, before we start factorizing, make sure we simplify it so that everything will be much easier. Okay, next, just factorize it. Now, to get 2x squared, it is just the product of 2x and x. And for 2, our factors will be 1 and 2. So I shall put the 2 over here and 1 over here and check. The inner pair, we have x. The outer pair, we have 4x. Now, to get positive 3x, what is the combination here? It has to be positive 4x here and negative x here. Therefore, we put negative in front of 1 and we put positive at the back. All right, and then double check. So negative 1 times 2, we will get negative 2. So our factorization is correct. So let's just erase this part after we double check. Okay, so equals to 0. Therefore, x equals to half, or x equals to, sorry, this is positive, yeah? So x equals to negative 2. And what is x? X is actually tangent A equals to half. And we reject tangent A equals to negative 2 because A is in the first quadrant. In the first quadrant, all trigo functions should be positive. So this is our answer for part A. Now let's look at part B. We got to show that tangent half A equals to root 5 minus 2. Now, when you see this one, we can still apply the formula of double angle. Okay, just change something. All right, no need to memorize the half angle formula because it's actually coming from the same double angle formula. We just do some modification over here. How? Like this. Tangent to half A is actually A over 2. All right. So isn't it double angle? Tangent to theta will equals to 2 tangent theta, and that theta is A over 2 over 1 minus tangent squared theta, which is A over 2. All right. Now, isn't it tangent 2 A over 2 is actually tangent A? And we just found our tangent A value in A. So let's just put everything. And at the same time, I will just let y be tangent A over 2. Okay, so let's just replace with the tangent A over 2 with y. So we will have 2y over 1 minus y squared. All right, and tangent A we just found in part A, which is half. So let's put in half equals to 2y over 1 minus y squared. So rearrange like what we did just now. So 1 minus y squared equals to 4y. Then we will have y squared plus 4y minus 1 equals to 0. Now for this one, we know that it's impossible to use the factorization like this. So we have to apply the formula. So remember how to solve the quadratic equation using the formula. That will be minus b, which is 4, plus minus square root of b squared, which is 16, minus 4a, and c, which is negative 1. And then over 2a. 2a, a is 1, so it's just 2. So we have minus 4 plus minus. All right, inside this 16 plus 4, we have 20 over 2. Now let's do this. Factorize two terms with the 2, like this. Negative 4 over 2 plus minus root 20 over 2, which the third 20 can be written in the product of 5 times 4, isn't it? Yeah, third 20 equals to this. And therefore, we can rewrite like third 4 times third 5. And therefore, third 4 is actually 2. So I can just put 2 third 5, whereby the 2 and 2 can be simplified. All right, so we will have negative 2 plus minus third 5. Negative 2 plus minus third 5, but we reject the negative part. Why? As I mentioned, if A is in the first quadrant, therefore the tangent value in the first quadrant will always be positive. So we shall reject the negative part. Okay, so we reject negative 2 minus third 5. So we have just proven that tangent half A equals to third 5 minus 2. So proven. That's it. Okay. If you have more questions, you can just leave your question in the comment section. Thank you very much.